Okay, so let's continue our discussion about oscillations. And again, these have something to do with the simple harmonic motion. So the objective of this lesson is for you to know the properties of this what we call simple harmonic motion. Okay, so we're done already with the first part dun sa recorded session natin. Yung huling in-upload kong recorded session sa Google Classroom natin. Okay? So I just want you to remember, ito yung paano natin i-describe. I just want to give emphasis kung paano natin i-describe yung tinatawag natin na simple harmonic motion. So we can describe the SHM through these three properties. So we have the amplitude that is pertaining to the height of our wave. Okay, since we're talking of simple harmonic motion, so therefore we can visualize it by or through a wave. Okay, so yung height ng ating wave, that is our amplitude, and it's measured from the origin or the principal axis. Ito, ang principal axis natin dito, class, ayan, yung nasa gitna. Yan yung lumalabas na origin natin or yung principal axis natin. So from the principal axis going to the highest point of our wave, okay, that is the amplitude. Or it could be the distance from the principal axis going to the lowest point of our wave or the trough. Okay, so pareho lang amplitude ang tawag dyan, ha? So it could be from the origin going to the crest or from the origin going to the trough. Amplitude lang yan. Okay, pareho din amplitude ang tawag dyan. Then we also have the period. It's pertaining to the time it takes for one complete cycle. Okay, so it's the time it takes to complete one cycle of motion. So pag sinabi natin one cycle, example, eto half cycle yan. Mula sa point na to, tignan niyo yung cursor ng aking sa screen natin. So mula dito sa point na to hanggang dito, half cycle yan. So mula dito hanggang dito, another half cycle yan. Therefore, mula sa point na to, passing through this hanggang dito, yan. Yan yung tinatawag natin na one complete cycle. Diba? Kaya one complete cycle, parang makakabuo ka ng isang circle. Kaya siya one complete cycle. Ganun ha? Therefore, ito example ko dito, ano to? 1.5 cycle to. Kasi meron pa tayong half cycle dito. Okay, pero kung one complete cycle lang ang pinag-uusapan, ayan, mula dito sa point na to, ayan, hanggang dito. So, babalik ka ulit sa principal axis para sa one complete cycle. Okay? Then, so yung period natin, yun yung time needed to complete one cycle. Okay? Then, yung frequency naman, that is pertaining to ilang cycle ang nagagawa sa loob ng isang segundo. Yun yung, kasi ang metric system of unit natin is second. So since we're talking of the frequency here, therefore, how many cycles can we have for 1 second? Okay, so let's say in 1 second, dahil mabilis ang pag-ikot, it could be 100 revolution per second, diba? So that is RPS, diba? Revolution per second. So 1 revolution is also pertaining to 1 complete cycle. Okay, kaya diba si planet Earth, every 365 and 1/4 days, nakakakompleto siya ng 1 revolution or 1 complete cycle. Okay? So, ibig sabihin, halimbawa, let's say, kung ang taon natin ngayon is 2021. So, ibig sabihin, nakabuo na, base sa calendar na ginagamit natin, ha, nakabuo na ng 2021 cycle si Earth sa kanyang nakakumpleto na ng 2021 revolution or 2021 cycles si Earth around the Sun. Okay? Kaya kada isang taon nakakakumpleto ng isang revolution or ng isang complete cycle ang isang planeta. Yan ha. So, itong tatlong tayo yung pinaka-importanting bagay na pwede natin gamitin for us to describe the simple harmonic motion. But aside from that, also we have the wavelength. Yung wavelength class, distance yan from crest to crest or throat to throat. Okay? So again ha, distance ito, pag sinabi nating wavelength, distance between identical points. O pag sinabi nating identical points, so therefore, kung crest yung reference point mo, dapat crest din yung magiging endpoint mo. Kaya dito, dinidescribe ko sa atin as distance from crest to crest or throat to throat between consecutive waves. Kailangan magkasunod. Halimbawa ito, di ba, magkasunod to. Ayan, di ba? Kung kumpleto to, halimbawa ganyan, magkasunod na dalawang cycle yan. So therefore, ang wavelength natin dito is from this point, yung crest ng unang cycle natin, doon, papunta doon sa crest ng kasunod. Kasunod, kailangan kasi consecutive eh. Okay? Nung kasunod na cycle natin. Ayan, so ito, wavelength din to, from throat to throat. Ganyan, okay? Then we can also have the frequency, di ba? Yung number of waves na dumadaan per unit time. Depende sa bilis ng wave mag-travel. Ganyan, okay? Then, paano natin ma-determine ang speed ng ating simple harmonic motion? It could be equal to the wavelength multiplied with the frequency. Since the frequency nga yung nagsasabi na ilang cycle ang magagawa or makukompleto sa loob ng isang segundo, since second ang ginagamit natin na metric system of unit for time. Okay? So, yun lang naman yung gusto kong bigyan ng emphasis dito. Okay? Then, tuloy na natin. Eto, dito tayo naputol dun sa recording session natin. So, para mas maintindihan nyo yung spring constant, di ba? Natatandaan ninyo? Meron tayong equation na gagamitin if we are talking of the simple harmonic motion. Yun yung equation sa Hooke's law, which pertaining to the restoring force. Okay? So, di ba, yung elastic force na sinasabi natin, according to Hooke's law, is equal to negative K multiplied with X. Wherein yung K natin is the spring constant. And tandaan ninyo, negative siya since it shows the restoring force. Ibabalik kasi. Ibabalik. Kaya restoring, di ba? Ibabalik. Eh, di ba we all know na for sign convention, pag bumabalik yung motion, ginagawa natin siyang negative, di ba? So dito ganun din. Dahil nga restoring force siya, kaya yung K natin, ina-assign siya as negative. Okay? That tends to move the object back to its equilibrium position. Since we're talking of elastic force here, we are pertaining to elastic material, di ba? According sa Hooke's law, yun yung unang-unang concept na binigyan ko ng emphasis nung nakaraan. Ayan, di ba? An elastic material returns to its equilibrium position after any applied force is removed. Diba? Sabi sa Hooke's law, ang general concept ng Hooke's law is that pagka daw nagkaroon ng application ng outside force or ng external force doon sa elastic material, at once na yung external force na yun ay na-release or nawala doon sa object, bumabalik siya sa kanyang equilibrium position. Di ba? Parang yung pendulum. Di ba? Pagkatapos ng mag-swing, babalik yun sa kanyang equilibrium position, which is yung gitna. Di ba? Pag nakahang siya. Di ba? Yun yung equilibrium position niya. So it doesn't matter kung gaano kalakas yung na-apply mo na external force, babalik at babalik yun sa kanyang equilibrium position. So yun yung sinasabi sa Hooke's law. Once na natanggal or naalis yung external force na yun, babalik yung object sa kanyang equilibrium position. Pero in elastic material, just like rubber, example, okay? Yung Hooke's law, may hangganan siya. Ibig sabihin, kapag ginamit natin to, let's say sa elastic material, yung totoong elastic material, wag lang mag-go beyond the elastic limit, di ba? Kasi pag nag-go beyond the elastic limit, magkakaroon na talaga ng permanent deformation. So, ano sabihin mo? Madi-deform na talaga totally yung object. Hindi na siya babalik sa kanyang original state or hindi na siya babalik sa kanyang original na itsura. Let's say yung last step, di ba? Yung rubber band, pag nag-go beyond the elastic limit, mapapatid yun, di ba? So pag napatid, ano na yung permanent deformation na yan. Hindi na natin yung maibabalik sa kanyang original na itsura. Okay? Second one, Hooke's law is named after its creator, British physicist Robert Hooke. Diba? Pamilyar naman tayo kay Robert Hooke. who stated in 1678 that the extension is proportional to the force. Dito pa lang mga anak, magkakaroon na tayo ng idea. Ano ibig sabihin nun? Pag mataas yung external force na in-apply doon sa object, okay? Definitely, mataas din yung extension na mangyayari doon sa object. So let's say yung pendulum. Ayan, let's say, ito na lang ha. Kung makita ID ko, sa ko na naman nilagay. Ayan, halimbawa, ito siya. Ayan. Pag greater yan, ayan, halimbawa, greater yung displacement na mangyayari. Greater yung amount of force na i-apply. Pag binitawan, ganyan, greater din yung magiging displacement niya. Diba? Pag masyadong malakas yung force na in-apply dito, definitely, yung object natin, malaki din yung magiging displacement niya. So, yun yung sinasabi dito na the extension is proportional to the force. The law essentially describes a linear relationship between the extension of a spring and the restoring force. It gives rise to the in the spring. In other words, it takes twice as much force to stretch or compress the string twice as much. Okay, so example niyan kasi para lang mas mabilis niyo ma-visualize. Spring, bawa spring. Binatak mo ha. So the greater yung force na i-apply mo para mabatak siya, the more na mababatak yung spring. Diba? Pero the lesser the force na i-apply mo dun sa spring, definitely hindi din siya masyadong mababatak. Okay? So yun yung sinasabi natin na the extension is proportional to the force. Kaya nga, kung elastic material ang pinag-uusapan natin, pag nag-go beyond the limit ka na, okay, the elastic limit, ibig sabihin too much yung force na in-apply. And dahil too much yung force na in-apply, hindi na na-hold nung elastic material yung force na yon. Kaya nagkaroon na siya ng total deformation. Yan ha. Okay, however, like many approximations in physics, Hooke's law is useful in ideal springs and many elastic materials up to their limit of proportionality. Ito yung sinasabi ko kanina, di ba? The key constant of proportionality in the law is the spring constant. Okay? So, ibig sabihin, class, applicable lang si Hooke's law. Okay? Generally, applicable lang si Hooke's law kapag nandun pa tayo sa limit of proportionality. Ibig sabihin, pag hindi pa nag-go beyond the elastic limit. Katulad nga ng paulit-ulit yung sinasabi kanina pa. If we go beyond the elastic limit, therefore mga anak, hindi na natin masusunod yung Hooke's law. Kasi hindi na babalik eh. Hindi na babalik yung object sa kanyang equilibrium position. Hindi na babalik yung object sa kanyang original na itsura. Magkakaroon na kasi ng permanent deformation. Applicable lang si Hooke's law kapag, if and only if, bumalik. Bumalik yung object sa kanyang equilibrium position. Pag hindi bumalik yung object sa kanyang equilibrium position, ibig sabihin, nalampasan na natin yung limit of proportionality. Okay, so the size of relationship between the extension and the restoring force of the spring is encapsulated in the value of the spring constant K. The spring constant shows how much force is needed to compress or extend a spring or a piece of elastic material by a given distance. So, ibig sabihin ng class, kapag mataas ang spring constant ng isang elastic material, okay, ibig sabihin nun, mataas din yung restoring force na kailangan natin para maibalik siya sa kanyang equilibrium position. Okay, example, pag sobrang tigas ng object, di ba, ang hirap i-stretch. Yung ba, sobrang tigas ng spring. Di ba, may mga spring na gano'n eh, sobrang tigas nga talaga. Di ba, mga ginagamit na spring sa mga hydraulic machine, di ba? So, ang mangyayari doon, sobrang tigas niya, magre-require siya ng mataas na spring constant, di ba? So, ano ibig sabihin nun? Magre-require din siya ng mataas na external force if you wanted to test kung babalik siya sa kanyang original position or sa kanyang equilibrium position. Okay? And another thing, The value of the spring constant corresponds to the properties of the specific spring or other type of elastic object under consideration. A higher spring constant means a stiffer spring. So, ibig sabihin mga anak, pag mataas ang spring constant ng isang material, mas matibay. Yun yun. Okay? Mas matibay. Kaya pag mas mataas ang spring constant ng isang elastic material, ibig sabihin, nagre-require siya ng mataas din na external force if you wanted to prove the existence of Hooke's law. If you wanted to prove na magagamit mo si Hooke's law. Okay? Kasi sabi nga, mas mataas ang spring constant, mas stiffer yung elastic material. So, ibig sabihin, the more siyang mahirap i-stretch. Diba? The more siyang mahirap i-stretch. The resulting force F will also be higher. While a looser spring that easier to stretch will have a lower spring constant. In short, the spring constant characterizes the elastic properties of the spring in question. Okay? So, ibig sabihin mga anak, si spring constant, through the value of the spring constant, malalaman natin kung gaano ka-elastic yung isang material. So, ibig sabihin, pag mataas ang spring constant niya, okay, mas stiffer, mas matigas, kung titingnan natin sa rigidity, ganyan, mas matibay. Okay? Hindi siya madaling made-deform. Pero pag mababa ang spring constant nung material natin, ibig sabihin, mas madali siyang ma-stretch, mas madali siyang ma-deform. Okay? So, ito naman mga anak, ano naman to? Another way of computing the period in terms of Newton's laws of motion. Okay? So, solve natin to. Tingnan natin kung may apply natin yung ating value kanina ng spring constant. Okay? So, again ito yung value ng ating spring constant. Teka lang. Palit lang ako ng camera. Ayan. Wait lang ha. Burahin ko lang ito. Ginamit ko ito sa calculus kanina. Okay? So, ang ating elastic force is equal to negative k multiplied with x. Okay? So, ito yung magiging general equation natin. Ha? So, again, remember yung k natin is negative since restoring force siya. Okay? Stop presenting lang ako ha. Ayan, para mas makita niyo yung ano natin. Then, I will use na lang the problem dito sa ano natin ha, sa PowerPoint natin. Anyway, na-upload ko naman na sa Google Classroom natin yung copy ng PowerPoint presentation. Okay? So, a jack in the box lid, diba, I don't know kung nagkaroon kayo ng laruan na ganito, yung jack in the box. Yung pag pinipindot mo, or pag iniikot yata, pag iniikot, lumalabas yung clown, di ba? Pag medyo nervyosa kang bata, hindi nakakatawa itong laruan nito. Di ba? So therefore, dahil nagpa-pop up, merong spring sa loob. Di ba? Yun yung nagpo-cause kung bakit nagpa-pop up yung clown from the can. Okay? So a jack in the box lid will pop open when a crank is turned on the outside of the box. If Jack pushes inside the box with a force of 2.5 Newton, so ang force natin dito is 2.5 Newton, diba? For a while. Ito natin yung pintuan natin para medyo mabawasan yung liwanag. Ayan. Okay. So, ang force natin is 2.5 when the lid is closed and the spring is compressed. Pag sarado yung baksa, kaya yung spring naka-compress. Nai-stretch yung spring kapag nag-pop up na yung clown sa loob ng box. Okay? So, when the spring is compressed 10 centimeters from equilibrium. Okay? So, lalabas ang x natin dito is yung 10 centimeters. What is the force constant of the spring? So, therefore, we have to look for the value of K. Now, ito, dahil Newton yung force natin, so therefore, yung displacement natin dapat naka-meter, di ba? So, for every 1 meter, we have 100 centimeters. Therefore, this is equal to 0.10. 0.10 meter. Ayan, okay? Again ha, kasi naka-Newton yung force natin, kaya yung displacement natin dapat naka-meter. Ganun ha? Okay, so derive tayo ngayon ng equation natin para makuha natin yung K. Di ba ang equation natin is F equal to negative K of X. Di ba? So, iwan natin si negative K sa kabila. So, divide both sides by X. Para ito makancel. So, lalabas, we have now F over X equal to negative K. Di ba? Tapos, ang gawin natin, divide natin both sides by negative 1 para maging positive si K. Di ba? So, ito magiging positive na. So, lalabas. So, kung titignan natin, di ba, we have now F over X. Reciprocal nyo to, negative 1 over 1 pa rin naman yan, di ba? So, we have negative 1 over 1. Then, we have now K. Di ba? So, therefore, lalabas, negative 1 times F is negative F over 1 times X is X equal to K. Ayan. So, ito ngayon yung formula natin para makuha natin si K. Therefore, K now will be negative 2.5 Newton all over 0.1 meter. Negative divided by positive will give us negative. Diba? So, ang K natin ngayon lalabas negative. Diba? Ano sabi natin sa concept kanina? So, therefore, dapat talaga negative ang K. Diba? Base dun sa discussion natin, since nagdi-describe siya ng restoring force. Ganun siya, ha? Okay, so therefore, kasi lang natin. Therefore, we have now K is equal to 2.5 divided by the 0.1 is for a while. Okay, so 2.5 divided by 0.1 is equal to 25. So, K now is negative 25. Ang unit natin, Newton per meter. Newton per meter. Ayan. Okay? So, therefore, in terms of the metric system of unit, ang unit ng spring constant natin is Newton per meter. So, kung dyne, dapat kung dyne ang force nyo, ayan, ang displacement niya dapat centimeter. Para ang K nyo, ang unit is dyne per centimeter. Ganyan. So, kung ang force nyo is Newton, dapat ang displacement nyo ay meter. Therefore, ang spring constant nyo is Newton meter. Ganyan. Okay? Then, let's have the second example. Yung sa ano kanina, yung sa period. Again ha, nasa ano naman to, nasa Nasa Google Classroom naman natin to, ha? Hindi ko na isusulat yung problem. Okay. Juliet is pushing her brother Alvin on a swing that hangs from a tree branch by 2 meters long ropes. So, lalabas yung 2 meters natin dyan, that is the length. Ayan. Okay? With what frequency will Juliet have to push Alvin as he swings? So, ang hanapin natin dito ay frequency. Based sa definition natin, mga anak, frequency is equal to the reciprocal of period. Diba? So, that is 1 over t. That is why kailangan natin ng t bago natin makuha yung frequency. Now, ano kinalaman ng given na length sa pagkuha ng frequency? Sa pagkuha ng period. Therefore, gamitin natin yung formula na t is equal to 2 pi square root of length multiplied with gravity. So, we have now 2 pi. Okay, then ang length natin is 2. Ang gravity natin is 9.8, diba? Sabihin na natin na seconds to. Meter pala. This is meter. Diba, this is meter per second squared. Kaya itong meter matatanggal na. Pag kinuha natin yung square root ng second squared, matatanggal yung square. That is why, ang unit natin dito is second, which is a unit for period. Diba? So, period now is equal to, ilan ba to? 2.83 seconds. Okay? 2.83 seconds. So, may period na tayo, pwede na natin kunin yung frequency, di ba? So, this time we have now 1 over 2.83 seconds. So, our frequency is equal to 1 divided by 2.83 is 0.35. 0.35 revolution per second. Or that is RPS. Or pwede din ito, mga anak, 0.35 cycle per second or CPS. So, ito, revolution per second. Ito, cycle per second. Ayan. Okay? So, that is all about the description of the simple harmonic motion in terms of oscillations. Okay?